So we need to differentiate the Taylor series centered at 0 for the given function. We also need to identify the function represented by the differentiated series, and we need to give the interval of convergence of the power series for the derivative. Well, the Taylor series of function f of x can be written down as f of a plus f prime of a over 1 factorial times x minus a plus the second order derivative of f of a over 2 factorial times x minus a squared plus the third order derivative of f of a over 3 factorial times x minus a cubed, and let me move this a little bit, and so on. Well, now let's consider it for the given function f of x, which equals ln of 1 plus x. We get that f of x equals 0 plus the derivative of ln of 1 plus x with respect to x of 0 over 1 factorial times x plus the second order derivative of ln of 1 plus x of 0 with respect to x over 2 factorial times x squared, and so on. Let's simplify it. We get that this equals 0 plus 1 over 1 factorial of x times x plus negative 1 over 2 factorial times x squared plus 2 over 3 factorial times x cubed plus negative 6 over 4 factorial times x to the fourth power plus 24 over 5 factorial times x to the fifth power, and so on. Then f of x equals x minus 1 over 2x squared plus 1 over 3x cubed minus 1 over 4x to the fourth power plus 1 over 5x to the fifth power, and so on. So we can write down the series sum representation as equals the sum from n equals 1 to infinity of negative 1 to the power of n plus 1 times x to the power of n over n. Now we will apply ratio test and find the interval of convergence. So the ratio test states that if the absolute value of a n plus 1 over a n is less or equals q, eventually for some q between 0 and 1, then the series converges. If it's more than 1, then the series diverges. So let's consider the given series. This given series. In this case, an equals negative 1 to the power of n plus 1 times x to the power of n over n, and an plus 1 equals negative 1 to the power of n plus 2 times x to the power of n plus 1 over n plus 1. Then an plus 1 over an equals negative 1 to the power of n plus 2 times x to the power of n plus 1 over n plus 1 divided by negative 1 to the power of n plus 1 times x to the power of n over n. Then this equals negative 1 times nx over n plus 1. Then L equals the limit of the absolute value of an plus 1 over an, where n approaches infinity, and this equals the limit of the absolute value of negative 1 times x over 1 times x over 1 plus 1 over n, and this equals the absolute value of negative x. So from the ratio test, if L is greater than 1, series diverges. If L is less than 1, series converges. the absolute value of x is less than 1, so series converges. So we have found the interval of convergence. This interval is from -1 to 1. So when x lies in this interval, the series converges.